Hi everyone, I'm going to present my proposal of the evidence 2 of the subject analysis of electric circuits. My name is Gaspar Navarro Moreno. My matrícula is A0125-2422 and my teacher is el ingeniero Luis Carlos Félix Serrano. We need to identify our problem. So we have here a circuit with a 12 voltage source and then two resistance of 6 ohms in series. In the middle we have a 2 amperes current source, and then we have in parallel a resistance of 4 ohms, and we see at the end the terminal A and terminal B of the circuit. And so we have a Thevenin and Norton equivalent circuit. We need to determine the value of RL to obtain the maximum power that we're going to calculate in the next slides, and determine if an RL of 2 ohms hits less or more than RL of 4.5 ohms. So a quick steps to follow of our methodology: we need to determine all the problems that we will be solving, and in this case we need to start first turning off all the independent sources, find the voltage or current to point A and point B, and draw and model each circuit in equivalent form, and proving at the end using FALSAT a circuit simulation. So the first step we're going to do is we are going to calculate the Norton voltage source, and we see this is a problem of resistance. So we observe that the resistance of Norton and Thevenin are the same. So we see the result of 3 ohms that is obtained between the inverse of 6 plus 6, that are the resistance in series, equals 12, and divided between 4, the resistance in parallel, so we got 3. And in here, we are going to continue using a short circuit calculation. So we see the current between Norton and the short circuit are the same. So we first start with a fraction of voltage 1 less the voltage source of 12 between 6 plus voltage 1 between 6, and so we get equal to, and we get to the in the end voltage 1 equals to 12, and in the end, so we can get the current of the Norton and short circuit is dividing the voltage 1 12 between the resistor, and we get a value of 2 amperes. And in the drawing we can see the short circuit drawing. As we say before, we need then calculate the Thevenin equivalent circuit. As we obtain in the problem in Norton, the resistance are the same in both. We can use source transformation to solve this problem, and the resistance are the same in both problems. So we need to calculate the voltage source of Thevenin, that is equal of the multiplication of the current source of Norton and the resistance of Thevenin, that is equal to 6 the voltage. And finally we have a table with the results that give us the 3 results of current, voltage, and resistance in Thevenin, and in Norton we only get the current and the resistance, that is 2 amperes and 3 ohms. And we also draw both circuits. In the first situation, we see a problem where we need to obtain the value of RL, that is the resistance put in between A and B. We can see right here the formula of the power transfer, the maximum, the general formula. And as we see here, we have the power maximum, that is the fraction between voltage square of Thevenin and 4 and the resistance of Thevenin, that we got 36 between 4 multiplied by 3, so we get 3 watts. And then we calculate the power of L, and as we see, we only need to substitute all the values, and we are going to make the inverse of RL, and we get a value of 3 ohms. And the situation 2, we here get the power of each one using 2 and 4.5 ohms, and we get to the conclusion that it will hit the same, and as we see in the procedure, it get us a 2.88 watts, so it will hit the same amount each one. We can also prove this situation using Falstad. So finally, we have the simulation on Falstad of all the circuits made before, the original circuit, the Thevenin and Norton, and all the equivalent resistance made. And that's all for my part. Thank you.